Hi folks, so I'm very happy to have received what should be the final correct revision of my Burgerdisk PCB, and I'm going to start assemble it and then test everything. So I'm going to start with the small components so that it's easier, and I hope I'll be able to film that about correctly because I don't have a very good equipment for that. I just have my phone. So anyway, let's go and start with the little diodes here, there, and afterwards the two resistors, one here and one here. The diodes are polarized, so you have to mind putting the little line on the correct side. On the PCB, it's on the right, so I'm going to put it this way. The other one go the other way. And the last one is a different one. It's the one for the power distribution, to avoid putting back 5 volts to the Apple II in case you plug the programmer while the Apple II is connected, which is something you should not do even with this diode, just so you know, but I've put it just in case. Same thing, it has a little line that you should put the correct way in. Also, it's a little bit bigger, and my PCB is made with fritzing, so it's not perfect in terms of footprint, but that should be okay. Next, we have a resistor here, 330 ohm. These are not polarized, so you put it the way you want, and it's going to be fine. And the last one here is for the LED, so it depends on which LED you're going to put. I'm putting a blue LED in mine, so the resistor is 150 ohms. If you put a red one, you can go a bit higher. There are some tables on the internet to help you choose, and even calculators, so you can put in the exact characteristic of your LED, and it will tell you which resistor you need at 5 volts. So let's go and solder these. This iron is shit. real shit. Okay. So now we can cut the extra length of wire. Okay, done for this. So in the next step, I'm going to install a female DB19 connector, and I'm going to do it with the help of the enclosure, so that I'm quite sure that the tolerances are fine. So that is my enclosure. The PCB goes here. So I will align my connector. Insert it. Let's make sure it's correctly aligned. Yeah, I hope you can see. And I'm going to solder it now. I'm going to solder at least 2 pins before removing it. And let's finish that. This is going to be basically impossible to unsolder, so make sure you do it right the first time. I tried to unsolder one, and I needed hot air gun, and it was a fucking mess. Also make sure you put the female connector here, not the male one. Okay, that should be good. Let's do the other side. Okay. Let's make sure every pin is correctly soldered. None of them should move. This one is not soldered. Now it's good. And this one too. Okay, I'll check the other side. Good. So these connectors here are in case you have a DB19 with angled connectors, but it's not ideal because if you use these ones, you're not going to have the right layout to put the PCB inside the enclosure. So these ones are better. Okay. So let's continue with the IDC20 connector. These things have a notch so that you can't put it the wrong way around, and the notch is on the upper side. Like that. So let's go for 20 pins. Done. The next thing to put in is either the nano or the micro SD card module. We can do whichever one we want. I'm going to put in the nano. So this one already has its header soldered. And I won't solder it directly on the board, just in case, because I know better. I have 2 little strips of 15-pin header, with one here that is badly cut. So I just remove it and put it where I don't need it. Like this pin of the nano, the V-in is not used, so let's do it like that. The other one. So it's important to solder the things perpendicularly, and if yours isn't already soldered, I suggest you put the female headers and the male headers together, and then you do your little stack, solder on one side and solder on the other side. So of course the Arduino has a way to be put in. The USB connector should be on the left of the PCB. It's written underneath here, USB connector. And this is the programmer header that you should solder first, because otherwise you're going to have a really hard time soldering it if everything is stuck together. So let's go with 30 pins. And one here and one there, so I'm sure it doesn't move. Now I can do the rest. And here we are. Now the only piece remaining are the jumpers for use with Apple IIgs, for use on a Smartport enabled controller, and for the debug serial port, and then the micro SD. I'll start with the headers. So I'm sorry, I did something wrong with the phone and I did not film the soldering of this header. So now I'm putting these ones here, using some tape to stick them in place while I solder them. Sorry about the interruption. But well, you get the idea now. You put the pins in the holes and then you solder. Then there's a fourth header here for the LED, because the LED is going to be far from the PCB in the enclosure. So I'll connect it using connector cables, prototyping cables. Yeah, I have no idea how to put that so it's not in the way of the solder. Let's try that way. Should be good enough. This one is cold. Okay. And last thing to install is of course the micro SD module here. So I hate those with passion because while the pins angled, I want them to be straight. If I was better at PCB, I would replicate that kind of circuit myself and do it somewhat cleaner, but I suck at PCBs, so let's do it the wrong way. Straighten pins with pliers. Best result is 2x2. Like that. Yeah, these ones are going to be 3x3. And the last one. So make sure they are properly aligned, like this. And then this module goes aligned in both ways, of course. And this module goes underneath the PCB. So there are two rows of headers. I suggest you use these ones so that the micro SD module sticks out of the enclosure. It's easier to change the card. And then you just have to have it aligned enough for it to fit. Like this. So double check that ground and VCC and extra are the right places. Ground is near the top of the PCB, here, ground. That's what you need. Let's solder it now. Oh, it's very annoying. Okay, good. So you can clip the extra length of pins if you have some necessary hardware to do it. I'm not sure this one is strong enough. Yeah, it's not. I can't find my pliers, so I'll cut them later. I'm going to do a few tests to make sure everything is alright. With a continuity meter. Okay, so I'll check the grounds. Good. 5 volts. And phases, and I'll stop there because everything should be alright. Okay, so we are done on the main PCB. I'm going to close the jumper for Smartport advertisement because I'm going to plug this behind a Unidisk 3.5 floppy disk drive. And I'm not going to close the 2GS jumper because I'm going to use it on an Apple IIc, so I don't need it. Never close this or that if you're going to connect this device on a 5.25 disk controller, even with a safety speed card, because the problem is that this pin here is drive 2 for 2C and 2GS, but it's 12 volts on an old disk controller, and another one is 5 volts instead of being a serial, so that would not be very good. I'm going to put this aside now and start with the adapter PCB for the cable to the computer, so with a male DB19 and another IDC20. So same thing again, lots of soldering. I think I'm going to use that because it's going to move around everywhere and I don't want that. I suggest to start with the DB19 because it's harder to solder it after the other header. What's wrong with this iron? Did I turn it off or something? Okay, done. So another IDC20 connector that you have to put the correct way with the notch at the correct place and on the good side of the PCB, this one, not the other one. It's the side with the markings on the silk screen. Yeah, I forgot that it's going to move everywhere. And we're done. So we are done with all soldering. We can start assembling the thing in its enclosure. So let's take the bottom of the enclosure and put our PCB inside. I think this one is a little bit bent, because it should be easier. Yeah. Afterwards, you can put the SD card in its slot. Put your cable there. Put that apart for now. Assemble the adapter this way. That's kind of shitty, but it's good enough. And use two small 2mm screws. Not too long. And that's ready. Final step that is not 100% necessary, but I'm going to do because the floppy drive cables are quite thick and they tend to have the box move, is to put a little weight something like here. I'm gonna grab some glue. I'm not sure how epoxy glue will work on lead and PLA, but I'll try and we'll see. We'll see in half an hour if that's good or not. In the meantime, we're going to add the LED that I have somewhere. Here it is. It's a blue LED on which I've put a little bit of heat shrink so that the light doesn't diffuse too much. And well, we'll see if that's enough. So I'm going to grab connectors. Not those ones. Be right back. These ones. So ground is a short one. I think think it should fit as is. I'm kind of unsure. I should solder those, I think. Maybe I can try something like that. Yeah, no, it's a fucking bad idea. Let's solder them. So heat shrink. Scissors. More soldering. Yeah, I always forget the heat shrink. I'm not sure it's going to stick very well first time, we'll see. Seems like a great way to burn myself. Seems good enough. Going to be smarter for the other pin. Until the leg of the LED first. Should be easier. It's ugly but functional. Okay, so one last thing. Put the LED in its slot. Then plug it the correct way around, so I used brown for the cathode and red for the anode. Okay, it's time to test. This seems to stick somehow. So let's go and test. Of course, before testing anything, I have to program the Arduino, otherwise nothing is going to work. So I'm going to program it with this, an AVIA ISP programmer, because if you program it via USB, the bootloader is slow and the Arduino boots too slow to get the Smartport init packet, and nothing works if you boot from a floppy. So the header to program it goes this way with the red wire on this side, Then you plug it in the computer, and then in the Arduino IDE you set everything as should be. Arduino Nano at Mega 328p, and programmer is Avera ISP-MK2, which you can then upload using programmer. And this is done. So time to test this little device. I'm going to plug it into the Apple IIc. I'm going to plug the external disk IIc while I'm at it. And let's go. So we are booting from the internal floppy disk. Let's check internal floppy disk, external floppy disk. So this is chained by my device. Now let's check my device's partitions. This is A2 desktop. On total replay. So let's launch A2 desktop, for example. Well, I think that's working fine. Everything's there. So the last remaining thing is to close the enclosure. I'm going to change the cable because I have a defective drive, and whoa, this is tight. I'm going to remove it because this scares me a little bit. And I'm going to do it this way. This connector is really tight. This is scary. What the? Yeah, good. So as I was saying, I'm going to put my own Apple cable. That is going to fit nicer. Just have an issue with this piece of metal inside the enclosure. I don't want it. And I don't need it either. Good. Then I just have to manage to put it correctly. That should do nicely. this requires 4 screws. There might be some 3D printing strings in the holes, so remove them with the screwdriver. And here we are with a device that is ready